Hey, Math 20-1s. Today we're going to look at graphing linear inequalities in two variables. So we're going to start with the boundary line. Given any coordinate plane, you draw a line on it, such as y equals x. It's going to divide that plane into two regions. All right. Note that all the points in the line y equals x satisfy this equation. A couple examples: 5, 5, 0, 0, and negative 5, negative 5. Obviously, y equals x in all of these cases. All right. And like I said earlier, we now have a region above the boundary line. We've got a region below the boundary line. So it's going to separate the coordinate plane into two regions. One region is above, one region is below. If we look at the region above the boundary line, a bunch of these points as examples, we would notice that for every single point above the boundary line, y is greater than x. 5 is greater than negative 5, 4 is greater than negative 15, 1 is greater than negative 10. Negative 5 is greater than negative 12. Every single point above the boundary line has y is greater than x. Very important to remember that. If we look at the region below the boundary line, and again we use all these points, we will notice that for every point, y is now less than x. 7 is less than 14, 4 is less than 10, negative 2 is less than 2, and so on. Negative 5 less than 10. So every point below the boundary line satisfies the inequality y is less than x. So as we can see here, we now have three regions. Rather than two, we've got three. So the line will separate the coordinate plane into two sections, but the line itself is considered a region. So all the points on the line, that's one region. All the points above the line and all the points below the line. So if we look at the line y equals x, the three regions that satisfy this whole graph are y equals x, every point on the line, y is greater than x, every point above the line, and y is less than x, every point below the line. That would cover every possible coordinate plane point given. A couple things about the boundary line. So the boundary line for any inequality can be either solid or broken, and it's going to depend on whether the line is part of the solution or not. So some solutions will have the boundary line being part of it, some will not. Here's how you can tell the difference. If you're asked to graph y is greater than or equal to x plus 3, obviously we're going to graph the line y equals x plus 3, and y is greater than that, so we're going to shade above. Thus the green shading. This equal sign means that the line is included in the solution. So x plus 3 is part of the solution, so every point on the line satisfies the inequality. So all the shaded section and the points on the line, therefore we're going to make the line a solid line to indicate that the line is part of the solution set. So all the shaded stuff and the line satisfy greater than equal to, could be less than equal to. So the equal sign indicates the line is part of the solution. If the line is not part of the solution, such as the inequality y is greater than x plus 3, we still graph the line, we still shade above the line, but because it's just greater than, we no longer include the x plus 3, so the line is not part of the solution anymore. So we would now break the line, or draw the graph with a broken line. So this would indicate only the region above the line is part of the solution set. The points on the line do not satisfy this inequality any longer. So let's graph this linear inequality. Practice all things we put into play. Alright, so the first thing we're going to do here is isolate the variable y on one side of the inequality. So I'm going to move my negative 4x's to the side by adding 4x to both sides. So I get 3y is greater than 4x plus 12. I'm now going to divide both sides by the 3. So y is greater than 4/3 x plus 4. We're now going to be asked to graph this inequality. So we need a coordinate plane. Once we have our coordinate plane, I want to graph this line y equals 4/3 x plus 4. So now it's got a y-intercept of positive 4. We know it's got a slope of 4/3, so it's going to rise 4, and it's going to run 3 to the right, positive slope. So there's our next point. It could fall 4 and run 3 to the left. So we know what the x-intercept is, as well as the y-intercept. Y is greater than this, so if I draw my line, that's the line y equals 4/3 x plus 4. We want y is greater than that, so the line is not included, so we should make this into a broken line. Indicating that the line is not part of the solution set. And we should then shade above the line, y is greater than. So all this stuff that we can see in the graph, we're going to shade above that line. And that'd be the inequality, y is greater than 4/3 x plus 4, or negative 4x plus 3y is greater than 12. There's your solution, or your assignment. We will work on that in class on Monday. Have a good weekend.